Welcome to the Explainer. I am honestly so excited to share this one with you today. We're looking at a genuinely fascinating engineering challenge right at the very frontier of artificial intelligence, and that's managing an AI's memory. I mean, if you've ever interacted with an AI that suddenly, forgot what you were talking about just 10 minutes ago, you know exactly what I mean. But think about this. What happens when an AI is tasked with running a complex security investigation that lasts for hours? How do you keep it on track? Well, the engineering team at Slack actually just published an incredible breakdown of how they solved this exact problem. So today we're going to dive right in and look at their breakthrough architecture. So here's our roadmap for this explainer. We'll start with the context window challenge, move into Slack's AI security team, look at the director's journal, the critic's review, the critic's timeline, and finally, rethinking AI message history. We're going to dissect this whole multi-agent system piece by piece. Okay, let's dive right into Section 1, the Context Window Challenge. To really appreciate what Slack built here, we first need to understand the fundamental technical limitation of modern language models. And that brings us to the million-dollar question. How do you keep an AI on track when it effectively has zero memory? Because, under the hood, language model APIs are inherently stateless. Literally, every single time you ask the AI a question, it wakes up with total amnesia. To give you that illusion of a continuous conversation, the software wrapping the AI actually has to send the entire history of your chat back to the model with every new prompt. It's wild when you think about it. Now, that kind of brute force memory tactic, it works perfectly fine for short-run applications. If you're just, say, writing a quick email or asking a few basic questions, standard context window management is completely sufficient. But for long-run applications, like those complex security investigations, the traditional method completely falls apart. You're suddenly spanning hundreds of inference requests, right? You're generating megabytes of output. If you just keep stuffing a context window with raw history, the AI's response quality degrades, your API costs just absolutely skyrocket, and eventually you hit a hard technical limit. The AI literally just stops working. So simply accumulating messages like a giant group chat is a total dead end. Moving on to Section 2. Slack's AI security team. Let's look at the specific, incredibly high-stakes environment where Slack's engineering team actually had to solve this, their own internal security investigations. So Slack built this multi-agent system to investigate security alerts. It's basically a specialized team of AI models, each with specific jobs. First, a director orchestrates the whole investigation. Then, numerous specialist experts go out and actually gather evidence from server logs. And finally, a critic rigorously reviews those findings. To make this tangible for us today, we're going to anchor our explainer on a real-world scenario that Slack actually provided. We're going to track how this AI team handled a specific alert, a developer on a workstation who triggered a massive security warning simply by installing a pretty standard software package. Now, spoiler alert, it was a false positive, but tracking exactly how the AI team figures that out is where the real magic happens. All right, Section 3, the director's journal. This right here is the first pillar of Slack's memory solution. To manage this massive flow of information, they didn't just hand the director agent a raw transcript of everything the experts were doing. Instead, they gave the director a journal. The journal isn't some massive, chaotic text dump. It's a highly structured working memory. The director is actually prompted to update it constantly, categorizing its thoughts into one of 6 specific entry types: decisions, observations, findings, questions, actions, or hypotheses. And here's the kicker. Every single agent on the team gets to see this journal. It acts as their shared narrative. This is just brilliant because sharing only the journal, rather than those raw, noisy server logs, keeps the whole team perfectly aligned on the big picture. It completely avoids overwhelming them or triggering that nasty confirmation bias you get from way too much granular data. And this brilliantly illustrates exactly how the journal works in practice. What we're looking at is a real snippet from that developer investigation we just talked about. At 9:34 a.m., the director notes a high-priority finding. It suddenly realizes that the security alert was triggered simply because the developer's script path had the letters KMOD in it, not because they were actually trying to execute some dangerous kernel modification. By writing this specific realization down in the journal, the director cements this breakthrough into the team's working memory, doing it concisely and clearly. But hang on, how do we know the director is getting good information in the first place? That brings us to Section 4. The Critic's Review, which is all about evaluating findings to address the massive elephant in the AI room, hallucinations. Because look, when those expert agents go out and pull server logs, they might invent things or just totally misinterpret data. It happens, right? So the Critic agent is deployed to audit them. But the critic doesn't just read the expert's final answers and blindly nod along. No, the critic uses a specific set of verification tools. It uses things like get_tool_call and get_tool_result to essentially look right over the expert's shoulder. It audits the raw data the expert looked at and the exact methodology they used to get it. It's basically double-checking the math before absolutely anything is accepted as fact. To put that into perspective, Slack ran over 170,000 findings through this critic system, and the results reveal a pretty stark reality. Over 25%, yeah, more than a quarter of all findings submitted by the AI experts failed the plausibility threshold. They were either completely speculative or just dangerously misguided. Honestly, this data proves exactly why the critic's rigorous review process is absolutely non-negotiable. If you just pass raw AI outputs forward, your long-run application is, for sure, going to inevitably derail itself with hallucinations. All right, Section 5, the critic's timeline. This relies on narrative coherence as the ultimate filter for truth. Once the critic filters out the garbage, we move to this third and final memory channel. The critic's job here is to take those trustworthy findings we just talked about and build a pristine, consolidated chronology of our developer's false positive event. It strips out all the duplicate data. If two experts report the exact same alert, it only goes on the timeline once. And if an AI tries to hallucinate a fake event, it'll almost certainly fail here because the critic enforces strict chronological rules. A hallucination simply won't fit logically between the time-stamped realities of the user session starting and the package operations actually initiating. It's like a giant puzzle, and the fake pieces just don't fit. But what happens when the timeline isn't perfect? Well, a truly intelligent system knows exactly what it doesn't know. The critic is actually programmed to identify gaps, missing data or weird logical leaps. But crucially, it actively limits its reporting to only the top 3 most significant gaps. In this specific case, they didn't capture the exact SSH login event, and they completely missed the triggering command document. By intentionally limiting these unknowns to just 3, the director isn't suddenly paralyzed by an overwhelming list of minor mysteries. It knows exactly where to focus its very next move. So, the crucial point is here in Section 6, rethinking AI message history. This is how all of this engineering brilliance comes together to completely rethink how we build multi-agent software. The Slack engineering team makes this incredibly powerful statement. Besides these resources, we do not pass any message history forward. Let that sink in. This is a radical departure from standard AI framework practices. They don't send the transcripts. They don't send the chat history. They literally sever the raw message chain altogether. What they're doing instead is a concept called online context summarization. By replacing raw, infinitely accumulating message history with these structured, highly specialized memory channels, the journal, the review, and the timeline, they maintain perfect AI coherence. This completely eliminates that dreaded context window limit we talked about earlier. It keeps API costs way down, and honestly, surprisingly, it actually boosts the agent's creativity and focus, simply because they aren't bogged down reading thousands of lines of irrelevant historical chat logs. They only see the refined, verified truth. And that leaves us with this final, incredibly provocative thought. Deliberate design beats infinite context windows. As context windows get bigger and bigger in the tech world right now, the temptation is just to throw more raw data at the AI, right? Just feed it everything. But Slack proves that more data isn't better. Structured data is better. So if you're building or using complex AI systems, ask yourself, based on what we've unpacked today, are you managing your AI's memory? Or are you just filling it? Thank you so much for joining me for this explainer. I really hope it sparked some new ideas for you, and I can't wait to see you next time.